But anyway, thank you everyone for joining us. It's been amazing to see we have 6 continents covered already this morning. We're always going for that 7th, but we haven't had any penguins decide to join us from Antarctica, but we have all the other 6 continents. I saw 2 people from Colombia, so scroll up and find each other and say hi to each other. There's been people from quite literally all over the world. Ukraine in the house, that's amazing. Spain and Portugal, Hungary, Switzerland, Romanistan. That's a first, I think, for Cube Crash. But many African countries, Somalia, Rwanda, Egypt, Nigeria. Just thank you everybody for joining, and so many Californians and West Coast folks, and someone from Mountain View. You at least working into it. So keep telling us where you're from. And the other note about the Q&A, I can see that, so we have chat, polls, and Q&A. We're only using chat. So ignore the polls and Q&A. Just ask your questions in the chat tab. I think that's all of our public service announcements for the time being.
Well, now we're going to move on to our next speaker, Lena Hall, who I work with at Akamai. So Lena, I'm going to bring you to the screen now. Welcome, nice to see you.
Hello.
And so you're here to talk about the infrastructure era of agentic AI. So I am going to, let's bring your slides to the screen.
That is a hot topic. Thank you for addressing it.
Just a small topic.
All right. Apropos to most of our audience here.
Yes, and then I'm going to, we're working through the backstage icons. All right, with that, Lena, we're gonna duck out and over to you.
Wonderful, thank you so much. This is a fantastic event. Hi everyone. I'm Lena. It's fantastic to be here at Cube Crash. Well, the teams are shipping the best agents right now. They're really the teams, not necessarily with the best models. They are the teams who really understand that before anyone else understood that agentic AI is really a distributed systems problem in disguise. We're dealing with stateful workloads, we're dealing with long-running sessions, with hierarchical scheduling, with locality. These are not really new problems, right? They are the problems that this community has been solving for years now. So that's what I want to talk about. Okay, can everybody hear me? Because I see some messages that people are stuck on the blank screen. Let me know. Okay, perfect. Let's move on. So for the last 3 years, the AI conversation has kind of acted like infrastructure is a solved problem. And the only thing that matters is the model, right? Like comparing GPT versus Claude versus Llama, over-indexing and parameter counts and benchmark scores. But I really see that conversation is changing. Because as agents move into production, the hard problems are not necessarily in the model layer. They're in everything around the model. And it turns out that these problems have a name. They are distributed systems problems. So welcome to the infrastructure era of agentic AI. So let me show you what I mean here. A traditional inference request is simple. Input goes in, the model runs, the output comes out, maybe 200 milliseconds latency. Stateless, it's standard request response. The kind of workload that a basic, web tier can handle just fine. But an agent in these days does not look like this. An agent is a loop. The model decides to call a tool runs. The result goes back into the context. The model decides what to do next. Maybe it spawns more sub-agents in parallel. Each sub-agent has its own loop. So each one can call more tools, and the whole session might run for minutes or consume thousands of model calls at times. So if you have ever operated a stream processing system, this can feel familiar. Long-lived stateful systems with back pressure and fan out. If you have ever operated a distributed database, the consistency and session handling questions are also familiar. if you've ever operated an orchestrator, the hierarchical scheduling may also feel familiar to you. So the teams treating agents like the new kind of web service are really struggling right now. But those who treat agents like a distributed systems problem are actually shipping great, reliable products. So what does this look like in practice? Start with inference itself. So not just GPU allocation, things like prefix caching across requests, because agents revisit the same context over and over. So KV cache placement is important, that knows which session a request belongs to. Things like speculative decoding. If you treat every model call as independent, you pay to tokenize the same prefix hundreds of times. And that is a routing problem. And routing problems have so much literature behind them already, so we know how to solve these. Then there is the question of where it all runs. Centralized inference made sense when a model call was a one-shot request. An agent is not necessarily a one-shot request. It's a long session that hits your databases, your vector stores, your internal APIs, your file systems. So it can be happening hundreds of times per run. The model can be slow, but the tools cannot be, because tools have to run close to the data they touch. As imagine your data can be in Frankfurt and your tool execution is in Virginia. So every step of the loop, there is a transatlantic round trip. So the inference and the tools also have to stay close to each other, because they're talking to each other constantly. And this workload is chatty in a way that one-shot inference is not. So users don't want to wait for 20 minutes before they get a first token or a response. They constantly watch the agent stream its work. So time to first token really shapes the user experience, even when the total session time is measured in minutes sometimes. So then there is a part that you really cannot engineer your way out of. For example, if your customer data cannot leave the EU, or if your healthcare data cannot leave the country, the inference has to come to the data, because your data legally cannot come to your inference. Then there is state. Agents have sessions. Sessions need to persist. They need to resume after a crash. They need to migrate when a node goes down without losing its place. So we have concepts like append-only logs, snapshot restore, session affinity that does not break when you scale out. So every one of these is a solved problem in the database world. We just need to bring those solutions to a new workload. State also leads directly into scheduling. When an agent creates sub-agents, those sub-agents need their own resource budgets, their own permission scopes, their isolation boundaries, workloads scheduling other workloads recursively with resource accounting across the tree. So if you've operated things like job scheduler, a workflow engine, or any orchestration platform, you already are familiar with the scope. And underneath all of this is execution. So the model is only one part of the workload. The tools that the model calls is the other part. And every tool invocation is a function execution. Very frequently, functions have cold starts, and very often they are short-lived. So if your tool runtime takes 500 milliseconds to spin up a container and your agent makes a lot of tool calls, you can add minutes of pure cold start latency to a single session. So the future of tool execution is sub-millisecond startup, sandbox running close to the inference that called it. And here's the pattern that I really would like for you to take away. Coding agents like Cloud Code, Cursor, Codex, they kind of independently converged on the same architecture. A loop, a context manager, a tool registry, a permission layer, an orchestrator. So different teams, different companies, but similar approach. And the industry is starting to call this a harness. Harness is becoming the unit of compute for agentic AI. So the way containers became the unit of deployment for microservices, the harness is what we're deploying, scaling, operating in the next few years. So the shape of this platform that runs harnesses is not really a mystery because it's distributed by default. It runs inference and execution close to the users, close to the data. It supports open weight models where you need them, not where someone else decides where you have to put them. It provides a lightweight sandbox function execution that starts instantly, and it has to treat sessions as a first-class state. And the last point is the AI industry has spent several years optimizing for the models, but I really believe that the next few years are about optimizing everything around the model. So that work is happening in platform engineering teams. It's happening in this community. So we all know that running real systems at scale is hard. State, locality, scheduling, and isolation, they're not just implementation details in the background. They are the product. So distributed systems experience and expertise is the real skill for this. Thank you.
All right, thank
Lena.
you. And we have a few questions for you. Andreas asked, is there an example of a public repo with an agent running in Kubernetes that solves the challenges being pointed out here?
Yes, there are a few. I'm going to grab a link and share with you in the chat. It might take me a little bit to find it. But
I'll ask the next question, and then maybe after we boot you out, you can come back and add that link. Michael asked a question about the distributed system problem in this context. Would you apply best practices from existing microservices patterns? And then if yes, which ones?
This is a great question. I love this question because I think most mistakes that I see people doing when they're building AI agents is they're trying to use prompts for control flow. So in a prompt, sometimes I see like multi-page instructions that mix instructions, style, behavior, and control flow. I would say we actually have to use control flow for control flow. So things like actual logic that orchestrates when certain steps need to run. That is a similar way we would do it with microservices, right? When we have logic that decides when certain criteria are met, we can call certain parts of the logic. With prompts, it's very easy to fall into the trap of letting the agent fully decide on the control flow, but then you lose the entire visibility of what happens if the agent actually makes the wrong decision and calls the wrong tool or calls the wrong other agent with a different role. So I think that's the number one recommendation that I have is don't underestimate the power of workflow orchestration combined with agentic models. With AI agents and services.
Awesome. Well, and so if anybody else in the audience has questions for Lena, I'm sure she will stick around and answer those. And Michael or Andreas, if you have follow-up questions, feel free to ask, and you'll grab those links. Thank you so much, Lena. I have the pleasure of working with Lena at Akamai, and she's so smart. So if you have more time to see any of Lena's talks, you definitely should. So thank you for being here.
Thanks, Lena.